welcome everyone to what is probably the last or one of the last talks of this event, and I'm very excited and also honored and privileged to host two of the OGs and really stellar figures of cryptography, of modern cryptography. We have here Professor Shafi Goldwasser, Turing Award winner, and if I go over the list of awards, all of our time will be up. But one thing she co-invented is the concept of zero-knowledge proofs. And Professor Boneh, who again, if I go over the list of all awards, our time is going to run out, Gödel Award winner, among many other things, who invented pairing-based cryptography, co-invented. So I'm going to both be the host, but also answer some of the questions myself. And without further ado, I don't know, by the way, the timer isn't running here, so we can probably go on forever. I'll just take the time. Okay, so the first question is, how did you get into cryptography research? Maybe, okay.
Okay, so I guess I took a course from Manuel Blum on algorithmic number theory, and at the last, this was in the 80s, 81 actually, and in the last few lectures, I think it was last 2 or 3 lectures, he said that there's this exciting new field called modern cryptography, and at that time there were 3 papers. There were essentially the paper by Diffie and Hellman on modern directions in cryptography, and then there was the RSA paper, then there was a Merkle-Hellman knapsack-based system, and there was a paper on mental poker, which was a proposal by RSA, by Shamir, Rivest, and Adelman, I think it was SRA, for playing a game. As I saw, a lot of talks here are playing games using the blockchains, but playing a game over the internet of poker between 2 players without a deck, obviously, a physical deck. And the thing is that then there was another paper by Lipton, who was Dan's actually PhD advisor, who pointed out that there was a problem with the protocol. It leaked some partial information and people could tell something about other people's cards. So as a result of this class, I went through a project with Silvio Micali. We said we should invent a new mental poker protocol where we don't leak any information, where you could sort of prove that you don't leak any information based on some hardness in crypto, factoring hardness. And the point of the whole story is that in order for this protocol to work, you had to prove to each other that you're following the rules of the game. But you had to prove it without actually revealing anything else about the cards. And in order to prove that, we came up with a protocol which later is really the basis for zero-knowledge proof. So we proved that you follow the rules without giving anything else, except we didn't define it at that time. That took a little while longer.
Done.
How did I get into crypto? Oh, okay. Well, I'll keep it short. How much time do you have? Yeah. Let's see. So for me, I started a little bit later. Let's see. I always loved math as a kid. I would always go to these, obviously, like normal kids would do. I go to math competitions and all that. And one of the other things that I loved was also to kind of break copy protection on games. Yeah. And when I learned about cryptography, actually, I was like Shafi. I took a course in college by Shimon Evan, and it was an amazing course. That course, like literally, I was sitting with my mouth open throughout all the lectures. It was an incredible course. I just fell in love with the area. And what's interesting is, just as a piece of advice, I can say is it was clear to me that I want to do cryptography for the rest of my life, and that's actually what I did. So it's very easy when you fall in love with the area that you're excited about. It's very easy to devote the rest of your life to it. But it's interesting, when I started my PhD in Princeton, this was '92. I actually talked to a bunch of cryptographers in the area, and it was surprising. Multiple cryptographers in the area would tell me, there's nothing more to do in crypto. 1992. There's nothing more to do in crypto. We have BGW to solve MPC. We know how to do public key encryption. We know how to do signatures. The field is solved. There's nothing more to do. So I'm stubborn. I didn't listen. I continued. And of course, this was, none of it was being used at the time. So the lesson in this is, it's good to somehow, if you believe in something, it's good to go with it, and don't always get discouraged by what other people say.
I must say that this sentence that you said that there's nothing to do in cryptography, I have heard this also. Every 5-10 years, it's, everything has been done. And I think it's really because a lot of really kind of huge breakthroughs were done, and then it seemed like it's everything. And it has proven to be false time and again.
It's true, actually. There's never, in this field, there's never a dull moment. Yeah,
Not a dull moment.
It feels like there's always new things. You know, pairings come along, lattices come along, quantum computing comes along, blockchains come along. There's like never a dull moment. There's always new things to work on. So.
I'll give my answer to how I got into cryptography. I would say that I never really got into cryptography, even till this day. And I don't view myself as a cryptographer. And first few times that I was asked, oh, you do cryptography, or how did you get into it? I was surprised because I did a very different branch of computer science that's called complexity theory. And somehow through that, and actually through blockchain, I ended up being called a cryptographer, but I don't view myself as one. So I'm yet to make my entrance into cryptography one day. But question. So do you engage with cryptographic practice, with practical stuff? And how do you, if you do, how do you view the similarities and differences between the practice and academia? Maybe let's start with you, Dan.
Do you want me to go first? Yeah. Sure. Yeah, of course I engage in the practice of cryptography. I love it. Actually, one of the things that I think is so exciting about cryptography is it's such a broad field. And it goes all the way from very, very deep mathematics, which is great. That's kind of where I live and what I love to do, all the way to the most practical, when people talk about specific machine instructions and architectures, it's such a broad area that there's always things to do for everyone. So by the way, we should probably also say that the cryptography community, which is not the same as the blockchain community, the cryptography community, it's probably around 1,000 to 2,000 people worldwide. It's a very friendly community. Everybody's very kind of working together. There's these 3 annual conferences every year. It's a very fun kind of community to work in. So yeah, and it spans all the way from very theoretical to very practical. Maybe the way I would maybe look at the two sides of the field, kind of maybe, as you say, the more theory versus the more practice-oriented. I would say maybe the more theory side tries to basically prove that certain cryptographic tasks are possible under minimal assumptions. Yeah, what are the least possible assumptions we can do to prove that something exists? Maybe we don't care so much about efficiency, we just care about whether it's possible or not. And the practical side of things maybe is sort of the opposite, right? We try to build the most efficient systems, and maybe assumptions are we use idealizations and maybe stronger assumptions. And both sides are really important, right? I mean, there's two sides. There's a lot of interaction between the two sides. I think both sides learn from one another. And so, I think it just makes the field kind of more interesting that there's kind of two types of problems to work on.
Maybe I'll go, we'll alternate.
Sure.
I'll go second, and then, in terms of my practical experience, it has only been in blockchain. So I don't know, what, real security looks like, SSH or RSA or whatever
TLS,
it is.
Yeah, you should say TLS.
What?
TLS.
Sorry, TLS. So I don't know what happens there. But I actually find a lot of similarities between the culture within at least blockchain and the culture within academia. They're both very, very meritocratic, which means it's non-hierarchical. And if someone, let's say, young and brilliant comes along, then they rise very quickly to the top. I think that in proper, Web 2 or enterprise security is probably less like that, and it's more like, you go through some hierarchy and you progress slowly. And then I just find, again, in blockchain, there's this just amazing match between what is actually needed and the kind of assumptions that cryptographers are very good at saying, if you only have these assumptions, here's a lot of stuff that you can do. It just happens to be the case that in the blockchain world and not in the conventional world, you really have these assumptions. For instance, the whole notion of proofs is one where you say, I don't want to rely, I cannot assume that I trust this computer that's doing something. And that's why in blockchains there's this proliferation of ZK proofs. But in the conventional world, they're today not yet needed, or it's not realized that they're needed, because you have all of these trust assumptions about, banks or Google or whatnot. So at least between blockchain and academics, I think that there's a lot of similarity and something that goes very well hand in hand. That's my answer. What about you?
So I guess the way I engage with practice is through this company that I've co-founded called Duality Technologies, and it's not dedicated to blockchains. It's actually dedicated to the idea that how do we collaborate on private data. When I say collaborate, we do some computation that based on the data. Maybe we run some collaborative analytics, and it has applications in medical areas. And let's say if you have information about the same patient in many different databases and you'd like to combine it or join it in order to run a study on many patients with, or maybe, genomic-wide association study for research. And in the financial industry, usually it's used for detecting fraud or for determining credentials, and then some maybe for cybersecurity, for coming up with statistics on attacks that are being attacked on different companies and different, that don't want to necessarily share that they have been attacked, but they'd like to find out what's going on. So it's all about collaborative on the private data. Now, what I have to say is that one of the differences between research and doing something in practice, like through a company, is that, at least that's what I believe, that in research you have a good idea or you have the best idea, then you will get the credit for it. I think that, when to succeed in business, it's a lot about marketing, it's about the state of the world, it's about things you sometimes don't have that much control over. Marketing you might, but the fact that you have crypto winter, it's not really your doing. So there's sort of like the pure kind of quality of your work versus a lot of other factors when you think about doing, bringing things to practice. And then the last thing is, the nice thing about the practical thing is that you have to really think concretely. What are the constants? How efficient is it? And you have to think about all the parameters, not just focus on one parameter that your paper might be better than others. So it sort of forces you to be honest in a certain sense.
Okay. Okay, next question is, how do you explain to non-experts what is it that you do? And what is cryptography about?
Actually, you should probably go take that first.
Okay, I'll take it first. How do I explain what cryptography is about? No, I won't answer that, but because I'm not a cryptographer, but I can try to answer what is it that we try to do. So I would say, well, I said this often, that it's, the way I explain it to non-experts is I say, it's all about integrity, which means how do you know that the right thing is being done when you're not watching? And it happens to be the case that through some brilliant mathematical concepts that were, invented initially by Shafi and a whole generation of researchers, and then honed and improved, it turns out that you can sort of come and do a few very simple checks when information is formatted in the right way. And by those very simple and efficient checks, you can assert integrity with no other assumptions. And that's just completely outrageous and has deep implications. But in the end, I just talk about integrity. Okay, who goes next?
Yeah.
How do you explain?
Okay, so I guess one thing about cryptography, I think you cannot explain it without invoking the word magic. It's sort of magical, right? The fact that you can convince people of facts without giving them the proof. The fact that you can compute on information without actually ever having access to it. So I always talk about this magic. Second of all, you explain it with examples, right? So you had your example, I think with zero knowledge, I usually use the colorblind example. How do you prove someone that color exists without actually giving them the power to have color, to see color if they're colorblind? And that the idea being that you can convert in general proofs to a sequence of mathematical challenges that if you know the proof, you could solve them. Otherwise, you can't, unless you're very lucky. So I think that almost all the zero-knowledge proofs can be described this way. And the last thing is that the way to explain it is that cryptography in general is that it's by the fact that it's extremely important to have what cryptography can give you. So it keeps changing what's important. So there was cloud storage, like that we wanted to take advantage of the cloud, but we didn't want to give our data away. And now people are talking about machine learning, right? So you want to be able to do all this fantastic stuff, but you don't want to give all your stuff away, or you want to make sure that the machine learning algorithms are working the way they claim, so that we don't go rogue. Again, cryptography can enable you essentially to use this technology without trusting whoever it is that's providing it, because they have to prove it to you that they're doing it correctly, and that they don't just like use your data, do whatever they want, and we all know where this can lead to. So because these things are so important, and cryptography enables you to have privacy, to have verification, whether it's efficient enough today or not, it's certainly in principle possible, and we've got to do everything we can to make this world safe. And just the last thing I want to say is that every talk that I give to general audience about cryptography starts with this paper by Judge Brandeis, where he says that we have the right to be left alone, and it's a very old paper. And that cryptography is really enlarging this first sentiment of Judge Brandeis to everything that we do today, cloud computing, right, ML, and so forth.
So I have to say, when I have a dinner conversation with someone who's outside of the field, they ask me what I work on, and I say I work on cryptography. The next question they ask me is, so which camera should I buy? And I say, no, not photography, cryptography. and then I have to explain what that is. But the interesting thing is that the more data we have online, the easier it is to explain what cryptography is about, right? So actually, everybody cares, right? We protect information, right? We make sure your data is what it is. We make sure you can compute. You don't have to give your data away and still get services back. So I really like the way Shafi says it. It does magical things, and I think it's really important to remember, especially for policymakers who think that if you need to have, for example, you need to be able to analyze data to look for crime and fraud, that necessarily means that you have to look at all the data in the clear. Yeah, people don't even, unfortunately, a lot of folks don't know or don't realize that cryptography is a way to kind of to eat the cake and keep it. Yeah, you can analyze data without actually looking at it. Yeah, it sounds impossible, but that's actually what cryptography lets you do.
Let's talk a bit about that, because in the news, like, it's all about now Tornado Cash and privacy as construed as something that is dangerous. So at least over cryptocurrencies. So what is the right way to allow, let's say, nation states to assert laws and also allow the public the right for privacy?
Yeah, that's a great question, and actually that's a very long conversation. This is not an easy.
We have a lot of time. Don't worry, they're not going anywhere.
That's right. Yeah. So look, clearly there's a need for privacy on the blockchain, right? I mean, on the blockchain. Let's just a simple example, right? If Stanford wanted to pay my salary in crypto, today everybody would know what my salary is. Right, that's a fundamental problem. So that limits what blockchains can be used for. If a company was building, a company was building cars and they wanted to pay their suppliers in crypto, the whole world would know how much they're paying their suppliers. And this is not tenable. Businesses can't operate this way. So clearly, there's a need for privacy on the blockchain. At the same time, we have to remember we live in the real world. The real world means we are subject to real world laws. So things that we build do need to be compliant with local laws and regulations. And so when it comes to privacy on the blockchain, there's a field that's literally waiting to be created, which is what I would call compliant privacy, which is how do we encrypt data on the chain, provide privacy on the chain in a way that's compliant with laws and regulations. This turns out to be a really difficult problem. So in fact, we have written papers on this. We're writing a new paper now to explain why compliant privacy is such a difficult problem. There are solutions that you can think of that make sense, but actually they don't work. Yeah, and so hopefully you'll enjoy reading this paper and come to appreciate how hard this problem is. But I think this is a challenge for all of us, all of you guys, and including all of us, can we kind of think of more ways to reconcile this conflict, this tension between the need for complying with laws and the need for privacy on the blockchain? Because again, you have to remember, without privacy on the blockchain cannot reach its full potential. There are certain applications that it simply cannot fulfill. So it's an area waiting to be created, and it's a difficult area. So lots to do in the space.
Shafi, what's your take on
So, so I guess years ago, whenever you would talk about this issue of privacy versus security or safety or something like that, they would always, you would sit with the FBI. I think Dan and I were in several panels like this, and they would talk about child pornography. Say, here's the example why you can't allow the privacy of people in peer-to-peer networks, because then you won't be able to prosecute them. So interestingly, recently we wrote a paper that shows that even that example is not exactly so clear-cut. Because it turns out that when, let's say, the FBI is going to go and persecute someone based on information they've gathered, there have been cases that the defense forced them to show their tools for the tools that they used in order to find out this exchange between the alleged criminals. And the FBI didn't want to show the tool because then they couldn't use it, and they had to drop the case. But if you were using something like a zero-knowledge proof or something, you could imagine a case, and that's what we were proposing, where the FBI would prove that their tool did not do things that they're not supposed to do, like they didn't plant evidence, they didn't, they really operated according to what they were supposed to do, and the defense isn't going to find anything, and not have to reveal their discovery tools. So even for the FBI to do their job, this might be a tool. So it's kind of seems like a contrived example, but it really isn't. So there's all kinds of laws of collecting evidence where this could be useful.
Actually, can I make one more point?
Of course.
In that, I think it's interesting, there's a lot of discussion. So I'm focusing on payment systems. Shafi's example was about communication systems. Privacy in communication systems and privacy in payment systems, those are two different topics. Privacy in payment systems is a very interesting area. As I said, it has to be, we live in the real world, we have to comply with certain laws. One thing that I wanted to mention is this area of central bank digital currencies, CBDCs. I'm sure you're all familiar with it. Central banks want to launch their own digital currencies, which will be used for payments. And there are many reasons why central banks want to use it. Access to the financial infrastructure. Perhaps reduce fees and so on. What's interesting is there are many ways to launch a CBDC. Yeah, and I should say one of the benefits of a CBDC is that it allows the government to collect statistics and have a better, or actually, it allows the central bank to collect statistics and have better visibility into the economy, so they can see how the economy is behaving in a very accurate way, which lets them, manage inflation, manage debt, and so on. But again, there's this in this design of CBDCs. It's interesting. If you clearly, when you build a CBDC, you'd like it to be private, right? We'd like to be, I should be able to pay my doctor without anybody knowing that I paid my doctor. So there should be a privacy in a CBDC system. And yet, one of the benefits of a CBDC is it's supposed to give the central bank visibility into the economy. So again, we have this conflict. If we have full privacy, it sounds like you can't get the statistics you want, whereas if you can get the statistics you want, we can't have full privacy. And again, I want to emphasize, because this is really important to remember, that cryptography can completely resolve these tensions. Yeah, there are systems, if you want to look it up, one such system is called the PRIO system. There are systems that let you keep all the data private, so transactions themselves would be completely hidden, and yet aggregate information about the economy would be visible to the central bank. Aggregate information, so they won't be able to look at any single or even sets of transactions, and yet aggregate information would become visible. Again, it sounds impossible, but cryptography makes this totally feasible. So when it comes to designing such things like CBDCs, again, it's very, very important to have cryptographers in the conversation to make it clear what's possible and what's not possible.
So I want to leave some time for a question or two from the audience. So think if you have. I'll just ask you, a closing question, prophetic one. So 20 years out, where is ZK used?
Well, Shafi should start with that.
So first, there's a saying, I guess, in Hebrew, that prophecy was given to fools. So very hard to tell. But hopefully, it will be everywhere, for your credentials, for redacting documents, for governing, machine learning without necessarily having to look at the code, But these are things that I can already imagine now. So in some sense, 20 years from now, I don't know. Maybe Dan does.
Yeah, I mean, I totally agree. It's going to be used everywhere. I mean, even if you look at things that we need it for today, advertising, right? Advertisers need to be able to reconcile ads that you look at versus purchases that you do. Today, they do it by looking at the data in the clear. Well, why do they look at the data in the clear? We can do this. We can reconcile, basically what's called attribution. We can do attribution for ads in a way that doesn't look at everybody's data. So ZK will be used there. When you look at provenance of data, where did data come from? Everybody's worried about deep fakes, right? Oddly, it turns out ZK can actually be used to help defend against deep fakes. Yeah, it's kind of, maybe you don't see the connection yet, so look it up. How does provenance help? How does ZK help with provenance? And you'll find some papers on this, so it can be used for that. So it's like almost every aspect of our life is becoming digital, and everything that's becoming digital, ZK and cryptography is going to be useful and will be used, if not now, then in the future.
I'll give my answer and then questions. To me, the prevalence of proofs in general is very much tied with open, free, and broad societies. Because, and I don't know, I'm worried actually. 20 years out, I don't know if democracies remain, right, and in what form, but if they don't remain and if there is no open society, I think there's rather limited use for, at least for ZK proofs. Why? Because we'll go back to this trusted party model. And if you have the government, let's say, running everything, the government is not going to prove anything to you. And you don't need to prove anything to the government. You're just going to give it everything. So I hope that 20 years out, ZK is prevalent because that means that we have very decentralized, broad, networks of social functions that don't rely on centralized parties, but I don't know if we'll be there. I hope so. I think it's a much brighter future. So now, time for a question or two. Any questions? Yes.
Hi, this is Victor. Thanks for all the sharing. And a lot of us might share the sentiment, or at least I do, that the development of the field is so fast. And for people like you, where do you get information from, and what are the most important advancement that we might have not known that you're most excited about?
Well, what can I say? I mean, as I said, there are, if you want to learn, so I hope you're asking about cryptography. So there's blockchains, there's cryptography, there's different areas here. But let's talk about cryptography. So there are, primarily, there are 2 or 3 conferences a year that focus on cryptography. You should come to these conferences. This is a great way to learn. Again, the community is very open, very welcoming. People are always happy to explain their work. There are preprint servers, right? So the famous one is, of course, ePrint, eprint.icr.org. All the latest and greatest work on cryptography, including snarks, and but other areas of crypto too, they go up there. There are so many papers every year that it's, I think we're all having trouble kind of keeping up. It's like, what is it, over 1,500 papers a year now get published. So it's a very active community, and those are basically the sources, at least for me, those are the sources of information.
I'll answer briefly that for me it's all Twitter these days, but I don't do serious cryptographic research these days.
I agree that it's difficult. I mean, this idea of going to ePrint, I used to do that. I don't do that anymore. It's just, I have a limited amount of time. I guess one thing is that there is this place called Simons Institute at Berkeley, which I am the director of, and we're going to have, in 2025, a crypto program, and there's a very rich library of videos. Every once in a while we have workshops. I think there was one on verification protocols just like a month ago, so that's another place to look at talks, which have been videotaped. But I think these days, there's so much out there, right? There's Twitter, there's blogs, companies come up with blogs, there's ePrint. You don't have to know everything. In some sense, there's this serendipity. you look around, there's something that catches your interest. Unless you're interested in a specific topic and you want to know the best paper on the topic, I don't think you can really hope to know everything that goes on.
Maybe just to promote the three of us selfishly, we all teach classes on this topic.
That's true too.
Take our classes. All our classes are videotaped. They're available on the internet for anyone. Take our classes. It's a good way to learn.
Okay, time for last question.
Hi. So I have a question regarding the company governance. And in today's world, most of the companies operate in the traditional corporate board manner, right? And do you think in the future, most of the companies will use DAO as their governing policies, or do you think it will turn into something else that kind of complies with the regulatories, or how do you see as a DAO governance as a moving forward?
That's a question for you, Ali.
I'll answer very briefly that I think companies are companies are functioning well. It's other areas of government I think I'm more worried about. But companies, by and large, I mean, I believe, the capitalist model is there are like hundreds of thousands of companies, and by and large, that's not the first thing I would fix in human society. But yeah, sure, DAOs are like cool. I'm not sure if for companies they're necessarily needed. For governance of blockchains, maybe, but like, but that's my...
Since you asked about DAOs, maybe I'll say my one sentence that I like to say about DAOs. So I work with a political scientist, Andy Hall. He's an incredible political scientist. And from his point of view, DAOs are like a godsend. They are the perfect mechanism for doing political science research, because if you have an idea for a governance mechanism, you code it up in Solidity, deploy it, and just you see how well it works in the real world. Yeah, so it's a godsend for political scientists. My view is DAOs today have a lot to learn from what humanity has learned over the last 10,000 years. Yeah, they started with direct governance, and well, the Greeks already realized that direct governance doesn't really work because people can't spend all their days voting, right? So then they moved to delegated governance. What's interesting is DAOs are kind of evolving in there are many experiments happening, many experiments happening, and DAOs are evolving in how they do governance. And my hope is that eventually DAO governance will become, because it's moving so quickly, everything's moved so quickly on the chain, DAO governance will evolve to the point where maybe real world politics will learn from DAOs, yeah? And so DAO research, in my mind, is pretty important because, as you probably know, we are all moving, probably over the next century, we're moving to a world that's going to be very different from the world that we grew up in, right? Our kids, maybe our grandkids, might be the last generation that needs to work for a living, right? And so that's going to require a very different society. And so, well, if it's a different society, maybe it needs to be governed differently, and DAOs are kind of a way, potentially, to experiment with ways to govern our society. So for political sciences, this is great, but also maybe the real world eventually will learn from DAOs as well.
Shafi?
Can't follow.
So beautiful, cannot follow.
Okay, so with this optimistic thing, let's all thank Professor Shafi Goldwasser and Professor Ben-Sasson. Thank you.